Okay, before I begin, I just want to say thanks to Dave Sadowski for asking us to be a part of this, and everybody within the Office of Research Alliances to put this together. I think it's a really great opportunity to see what is going on campus and all the great technologies that we have to offer not only the Rutgers community but the surrounding community as far as biotech industry goes and the surrounding pharma industry. My name is Mike Pierce. I am the manager, so to speak, of the SEBS core facility. I manage the day-to-day operation of the facility itself. Up here is my email address. If you have any questions, comments, any questions about particular pieces of instrumentation that we have, please feel free to just send me an email, or if you can find my number anywhere online, just give me a call. I'd be happy to entertain any questions that you may have. If I don't have the answers, I'll find people who do. To get those questions answered for you. As Nogan had presented, we have a website that's available that will show all of the instrumentation that we have, as well as our rates and any upcoming courses that we may be offering. We're located on the Cook campus in Ferran Hall on the second floor. My office is in room 206, and as Milgan had presented before, we have a variety of instrumentation that we have available for use. In addition to that, we also offer a series of short courses that we're working on. And one of the courses that I teach is the short course for real-time quantitative theories and instrument operation. These are some of the courses that we offer currently. The one I had just mentioned that I teach in collaboration with the folks from Life Technologies and ABI. Xiaoping Li also offers a course in label-free detection by Biacore analysis. She does that course in collaboration with the people from GE Healthcare. And coming soon, as Nogan had mentioned, we're going to be offering some courses in confocal microscopy with the people from Zeiss, as well as flow cytometry. That's made very, very easy with the Accuray C6 flow cytometer, and that's going to be done in collaboration with the people from Accuray and Becton Dickinson. Okay. I just want to go into a little bit of detail as to the course that I teach. It's a 3-day course. The first day is presented by Life Technologies ABI, and Scott Gardner, who is the field application scientist, is here to talk a little bit more about the type of instrumentation that we use within that course, as well as highlight some of the key components of real-time PCR. So the first day is it's about a half day of a seminar, and it's open to the public. It's free. As many people can come as they want. And what Scott will do during this time is that he'll give you a really good, thorough introduction to what real-time PCR is, talk a lot about the terminology, the different detection methods that are used in real-time PCR. He'll also go into some detail about singleplex versus multiplex reactions and the advantages and disadvantages of those. He'll also talk in detail about the quantitation methods that are used for real-time PCR. You'd be surprised how many different types there are out there. And then finally, he gives a very nice introduction to the actual instrument, which is called the StepOnePlus. Days 2 and 3 are taught by myself, and they're taught at the core facility itself. It's a completely hands-on, you're in the lab type environment, so unfortunately we have to limit to about 10 people. But this is actually good in a way because it enables each person who's taking the course to actually use the instrument and get some actual hands-on work with it. And it also fosters an environment of people asking questions, and there's a lot of one-on-one interaction between myself and the people who are taking the course. We use a model system that I developed and I currently use in my lab work. And we use this model system to detect changes in messenger RNA levels. And so it's not like we're just coming up with fake models in order to present the result. It's actual assays that I use in the lab almost every day. And then I also go into a certain amount of detail about multiplex assay development, which is of great interest to a lot of people. It increases your throughput, and it just enables you to do a lot more different types of quantitation techniques within real-time PCR. And so we spend a fair amount of time talking about multiplex assay development. And so by the end of the course, what I hope that people will come away with is a firm understanding of what real-time PCR is, the terminology that's associated with it, and the different types of quantitation techniques. The user will certainly become familiar with the StepOnePlus, the instrument itself and its operation, and they'll have a pretty solid understanding of what singleplex and multiplex assay development actually entails. And of course, with any lab type presentation or any type of lab type work, there's going to be some little hiccups in the road that will have to be troubleshooted, and we'll do our best in order to do that. And so, once again, this type of environment is very keen to that type of dialogue between the instructor and the students. And so here are just a few reviews that we've actually gotten after after we've given the course. The biggest hooray is that it's a real hands-on workshop. You're actually in the lab, you're actually working the instrument, you're actually getting data, you're actually trying to interpret results. We also have taken great pains to make the material very easy to understand, and that shows within the reviews that we get. These people were very happy that the material was presented in an easy to understand manner, even for those without any PCR experience. And also, we feel that we make an impact on people's research, as seen by the last little review here, is that somebody actually felt that taking this course opened up a new avenue for which they can take their research. So without further delay, I'm going to introduce Scott Gardner. He's a field application scientist from Life Technology, and he does the first part of our real-time PCR course, and he's going to talk a little bit about the StepOnePlus instrument and a little bit more about what real-time PCR is. Scott?
So in Mike's lab, there is the StepOnePlus, and I have here an image of what it looks like. It's got a touchscreen, so it's got a very nice user interface. If you've never done real-time PCR, it's as easy as just pushing a couple of buttons and you can get it run up and started. The software on the system is free, so you can download the software in the office, at your house if you really want to, do the analysis as you please, and it is a free download. Just to give you a little bit of a glimpse, I have a picture up here on the screen as to the dimensions. It's a pretty small, compact unit, which does not even need a computer to run it. You can actually use it as a standalone system. So if you're looking at saving benchtop space, one of these systems is pretty small and compact. There's a long life, very bright LED lamp. That is the light source that's being used for our real-time system. The block is considered to be a gradient block, which has 6 independently controlled zones of operation. And just to give you a little bit of a glimpse as to the capabilities of the system, there are 4 main emission color filters. So if you're looking at a very custom dye or a certain, even a very common dye, it can detect all of the wavelengths that you see here on the slide. What this allows you to do, and something I do cover during the real-time course, is how to do what we call as multiplexing, looking at the behavior of different probes that are labeled with different dyes, all within the same reaction. With 4 color filters, you can detect 4 color dyes all at the same time in a single reaction well. Just to give you a little bit of a glimpse as to the consumables that are used, there is a very low profile plate, which allows you to use a very low reaction volume down to 5 microliters. So this typically is seen as a cost savings because the lower the reaction volume, the less amount of reagents you use, the more money you save. Going along with this, the StepOnePlus also has the capability to run strip tubes. So if you're not running a 96 well plate, just 5 or 6 reactions or so, you can just use a set of strip tubes. The latest thermal block technology in the system allows you to run in what's called fast or standard mode. Standard mode would be a real-time PCR run, which is about 40 cycles in about an hour and 45. This is what's considered to be universal cycling conditions. Although if you're really in a time crunch, it can support fast cycling. So if you have a fast-enabled master mix. It means that you can cycle 40 cycles in about 40 minutes. And I have here just some of our latest master mix recommendations for running fast or standard mode. As I mentioned earlier, the software is free to download. You can do the analysis at any computer that has the software. Some of the key capabilities are that you can analyze literally up to hundreds of delta-delta CT runs in a single study, all within the software. So no longer are the days that you have to go through about 100,000 rows of data in Excel. You can now do all the analysis in the software. Also with delta-delta CT, you can normalize to multiple housekeepers or endogenous controls. You can group samples, so you can do group-to-group analysis, delta-delta CT. And if you have any melt curve applications like CyberGreen, high-resolution melt, protein melt, there is the capability to automatically detect the melt temperatures of the primary products in the tube. There is also the capability that you can have the software automatically analyze all the data for you. So there is something called the quality control flags, which will automatically scan through the entire data set and tell you that there might be an issue to check out. And if the system is properly networked, you can have it even email you when a run is completed or when calibration is needed. Some of the capabilities of the software, and all these things I discuss over the summer course. The software allows you to generate a standard curve. So if you have a set of standards, you put that high quality sample onto the plate along with your experimental unknowns. And what that will do within the software is that it will graph the CT values versus the absolute quantities of your standard curve. And then going along with that, it will take all of the unknowns that are on the plate, plug that into the standard curve to convert CT values into actual quantities or absolute amounts. So the software has the capability to do all the standard curve analysis for you, and there's even a standard curve, what I call a wizard, built into the software that allows you to very easily set this up within the software. Also, of course, our software allows you to do all the delta-delta CT math for you, and again, can't overemphasize the fact that whether you have 2 plates or 100 plates of data, you can merge all of the data files into a single study for delta-delta CT. Delta-delta CT is typically used when you're looking at assays that are roughly equivalent efficiencies. However, if you have assays that are not as efficient, you're not getting that same doubling of product, there is a little gadget in the software that allows you to take into account different assay efficiencies, plug in the different numbers for how efficient each assay is, and that will be taken into account for the delta-delta CT analysis as well. Our software also allows you to look at our genotyping, our SNP genotyping assays, which are ultimately 2 different probes labeled with 2 different reporter dyes competing across the same template in the same well. Going along with that, it will give you all the SNP genotyping plots. We call it the allelic discrimination plots, where it graphs the FAM versus VIX signal intensity. So you can very accurately and easily have all the data manipulation taken care of for you within the software. Going along with this, Applied Biosystems and Life Technologies, we have our entire line of gene expression assays. So if there's a particular gene you're looking for a particular species, we have a ton of assays already pre-designed. These are TACMAN based assays, so you get TACMAN sensitivity. And what these ultimately are a set of primers and probe already optimized for you. All the bioinformatics has been done, and a hot link for that would be at allgenes.com if you're interested. Just so you know, we also do have a small scale available, so if you're only looking to do a few reactions, this is now available as well. If we don't have the assay that you were looking for, we also have the assay design tool on our website, which allows you to put your own primer and probe sets, as well as just copy and paste the whole target sequence and it will design a 20x assay that you can order from us as well. Last but not least, this is also at Mike's lab. There is Primer Express software, which comes with the StepOnePlus, and this allows you very quickly and easily to automate all of their primer and probe design for TaqMan analysis. Going along with this, we also do have our complete portfolio of SNP genotyping assays. This would be the FAM and VIC probes pertaining to that particular SNP, already optimized in one single tube solution. The hot link for that would be at allsnips.com. So to get started on the StepOnePlus, we do have our user's guides, which are free to download off of our website. Although, if you show up to Mike's course in the summer, I do cover how to set everything up within the software, and then Mike follows up with actual lab experimentation. So the world of real-time PCR has expanded very greatly in the past 5 or 10 years or so. So what I have here is a list of a lot of the applications that are currently being performed on our real-time systems, including the StepOnePlus. 2 of which are brand new, which I've highlighted, are for mutation detection and protein stability. So these 2 new applications, they came out within the past year with Life Technologies and Applied Biosystems. For mutation detection, we call it qRT-PCR, or competitive allele-specific TaqMan PCR. And this is literally finding a needle in a haystack. It's literally, can you accurately detect those few copy molecules of mutation amidst of thousands or tens of thousands of copies of wild type in a real-time PCR reaction? All the assays that we have are related to mutations that are associated with cancer and disease. And the best way to find if we have an assay for what you're looking for is to look for your mutation of interest in the Sanger database. We do also have an internal positive control that can be spiked in to ensure that there are no false negatives. And I'll briefly describe what these 3 types of assays are in a couple minutes. Just to give you a little bit of a glimpse, we have over 800 assays related to all of the following genes. So for some of these genes, like EGFR, there may be 70 different mutation assays available. This is just our current lineup as of a couple days ago. The way these assays work with qRT-PCR is that you have a mutation assay, which is essentially your basic TaqMan assay, labeled with 2 primers and an allele-specific probe for your mutation. And this is actually going to proceed as usual for real-time PCR. What that's going to do is amplify all of your mutation strands or copies that are in your sample. What this is teamed up with is what we call an MGB blocker or an MGB probe. And this MGB blocker is basically an oligo that is going to just simply sit on, in this case, all of the wild type. And without any primers or even a reporter dye hooked up to it, it just sits on all of the wild type copies and just sits there and suppresses the signal from everything wild type. There's also the flip side of that. We could be amplifying the wild type target and suppressing all of the mutation target in the same sample. These are teamed up with and compared to a reference assay. These are known to be a TaqMan assay that is located in a mutation-free region compared to that mutation assay. The workflow is very, very simple. You pick the assay of interest. You basically generate all of the real-time PCR data, get all of your CT values from the StepOnePlus or any of our other systems. And then you take that data and export it into our free mutation analysis software, which can be downloaded off of our website. It's called Mutation Detector. There's 2 types of analysis, one of which we are looking at the expression of our mutation-free controlled assay and comparing that to our mutation assay. And ultimately, when you do all the number crunching in mutation detector, what we're ultimately looking for is simply, is that mutation present, yes or no? Basically, does our mutant assay amplify? And to make sure that nothing went wrong with your real-time PCR, that's where our mutation-free region assay would amplify in every reaction. Another type of analysis, you can do this in separate wells. You get the CT value of the mutation assay, compare that to the CT values of the wild-type assay, and that will give you a % mutation in a sample when all the data is calculated in mutation detector software. So here's a little bit of a snapshot of the mutation detector software, where ultimately it's a very simple software where you just take your data into it, and you'll get a couple of columns of data that will give you the % mutation, and simply yes or no, is your mutation present. Our mutation detection assays, they are still a limited amount of assays. We have 800 of them. The reason is that they've underwent very, very stringent quality control to make sure we can detect as small amount as literally 0.1% mutation. So literally finding 10 copies of mutation in the midst of 10,000 copies of wild type. Just to summarize that application, the quickest and easiest way you can get more information on which assays we have and more information on the technology and the chemistry, you can go to our website /CASPCR. The other hot new application that came out within the past year is something called protein thermal shift. And what protein thermal shift is essentially a protein stability screen. You can use it as a way to improve your protein prep work. You can identify if there's mutations or modifications with your protein. You can use it for high throughput ligand screening, protein-protein interaction, and so on. And some of the big advantages, not just on the StepOnePlus, you can do this on a 384 well system as well. It essentially, all it is just a very simple melt curve. So from start to finish, you put your plate on the machine and you run a melt curve. It could be as little as literally 5 or 7 minutes of a melt curve, or as long as a 30-minute melt curve, and you get some information about your protein pretty quick and easy. The way it works is that we have our protein in a couple wells on the plate, and we expose the protein to our protein thermal shift dye. This dye is going to emit its fluorescence in the ROX filter in the StepOnePlus system. And the way that this dye works is that it's an environmental dye. It's going to bind to anything hydrophobic in the tube. So what happens is that as you have the protein in the presence of the dye, if you slowly heat up the protein's tertiary shape is going to unfold. And as it heats up and unfolds, it exposes these hydrophobic pockets on the inside of the protein. As it does so, and as the machine heats up, the protein unfolds, the dye is going to bind to anything hydrophobic and send a very nice fluorescent signal. What this fluorescent signal essentially is a melt temperature. That's characteristic of the protein or the interaction that's taking place in that well. The keys to this are that the more stable the protein, the more amount of heat that's needed to denature the protein, and therefore a higher melt temperature. So changes in melt temperature are related to protein stability. Very, very simple workflow. We have our protein in the presence of the protein thermal shift dye. We generate all of the melt curve data on the StepOnePlus, or you can do it on any of our other systems. And then you take that data into our protein thermal shift analysis software. Here's some examples of what you can do with this application. I've seen this in one lab where they're doing a high throughput protein ligand screening. So here in a couple of wells, we see our protein melting on its own. And here in a couple of other wells, actually 4 other technical replicate wells, what these folks found was that if the protein successfully binds to the ligand, it forms a more stable complex. if it indeed forms a more stable complex or a positive interaction, it's going to take more amount of heat to denature that complex. So this is a really good way as a high throughput ligand screening to see if the protein successfully binds to a suspected ligand. Within our software, there's a very, very simple algorithm that could take one melt temperature subtracted by another one, and if you get a certain amount of degrees difference in melt temperature, you can call it a positive hit. You can also use this as a way of looking at wild type versus potential mutations in your protein. So it's always nice to have a control for each one of these examples where you can apply unknowns to the melt curve data. Here we see our wild type melting on its own in red. And then if we have a mutation, that may change the dynamics and the kinetics of the melt curve. So what these folks have found is that a difference in melt curve implied that there's a different mutation. What they've ultimately found were that there's two different proteins that mutated and then applied experimental samples to the melt curve to make a call about the protein. On the image on the right, here is the same scenario, just the customer also added a ligand. The beauty of doing this within the protein thermal shift software is that you can combine many, many plates of melt curve data all into a single study. I'm going to skip this one slide. I'm running a little bit short on time. But the last example I wanted to mention today is that folks are looking at this protein for protein antibody interaction to see if there's a positive hit with that as well. So here in the red or the pink in the background, you can sort of see our protein melting on its own in a couple of wells. We also see our antibody melting on its own in another couple of wells. And then if we see a positive interaction in a few other wells, we would see a difference in melt curve. So here, what these folks saw was a positive interaction where the protein was forming a complex with the antibody. In this case, we do see a little bit of unbound protein, a little bit of unbound antibody, but that can always be tweaked to suit your needs. So just to wrap things up with protein thermal shift, we do have a quick hot link on our website, which would be at lifetechnologies.com/protein melt. And just to give you a little bit of a glimpse at one of the latest, hottest topics in the world of real-time PCR, something called digital PCR. There's papers that are coming out on this, and we have a brand new system that's coming out on this for digital PCR. It's a very small system that can generate a ton of digital PCR data, which is extremely highly quantitative real-time PCR. And since I am teamed up with tech support, I couldn't help but always leave this on the screen. So if you are in the lab and you need the most immediate support, the folks waiting by the phones are excellent, and that would be at tech support. And thank you very much.